Therefore, this session presentation layer will enable us to represent the data so that I can easily interface my data to the application layer. So the application layer mainly concentrates on graphical user interface. Why? Because graphical user interface is whenever the user wants to run or whenever the user wants to communicate with any devices, means he will not be communicating technically, or he will be not be communicating through the use of addresses of the devices. Instead of that, what he will be doing is he will be doing in terms of names or in terms of icons. Okay, but by just mouse clicking on an icon, he should run that application. So means what, we should create a user interface in such a way that it will be easy for the user to use your application. So therefore, what we are going to do is the way you represent your data to display to the user, that is, we are going to call it as a presentation layer. So the presentation layer, it is responsible to format your data so that user can conveniently read and write information based upon the application requirement. So that will be done by the presentation layer. So as Rhea said, system layer, as I told you in the last class, it is all about doing the encryption and decryption for your data. So let's say whatever the information you are transmitting over the network, if it is very sensitive information or if it is very highly security information, means then, or it is very, it should not be reach to the unauthorized person, means then what we should do is we should do the encryption for that data. Okay, so how we are going to do the encryption of data, means there are so many algorithms are there, protocols are there. So by the use of those algorithm and protocols, so what we can do is we can scribble the data in such a way that even if the intruder or even if the third person want to access your data, means he cannot able to read what exactly you are transmitting the data. So therefore, what we do is we do the encryption mechanism when transmitting the data. At the receiver side, we will be doing the decryption option, so that the whatever the operations you have carried out in the transmitter side, only those operations will be known by the receiver only. The remaining people or the remaining person or the third person who want to access your data in the channel, if it is a wireless channel, anybody can access your data. So even if he can access the channel, and if he wants to read your data, means he will not able to read the data. Why? Because the data has been scrambled, so there is no meaning for the data. So therefore, what he tries is whatever the information you are transmitting, it will not be seen by the third person or the intruder. Okay, so therefore what we do is we will be doing a encryption and decryption. So there are different types of encryption algorithm are there. There is a AES algorithm are there, DES algorithm is there, RS algorithm is there. So depending upon the size of your information and depending upon what is the level of security you want to provide for the user. So it may be an 8-bit security provide, or it may be a 64-bit AES means encryption algorithm, or it may be a 124-bit of encryption algorithm. It may be a single stage encryption algorithm, or it may be a multiple stage encryption algorithm. It may be an exchange of private keys algorithm, or it may be an exchange of public key and private key algorithm. So based upon how you provide your security to your data communication, so based upon that you can implement or you can apply the encryption algorithm for your information. So whatever the encryption algorithm you are going to apply, the same information has to be known already to the receiver. Why? Because if you're using some algorithm at the transmitter end and at the receiver end, if the user or if the receiver doesn't know what encryption you have done, means then the receiver cannot able to decode the data. So therefore what you are supposed to do is you should have an agreement, or you should have a policies, or you should have some protocols. So before starting the protocol, you should broadcast some signaling information in such a way that what is the type of information we are transmitting, at which interval of time the data we are transmitting, and what is the type of capacity we are using between transmission, that is a transmission link capacity we will be knowing, and what type of frame levels or what type of modulation schemes we are using in order to transmit the data. that we will be using, and also what is the type of encryption and decryption algorithm we will be using during the data transmission, we will be knowing. Okay, so based upon the encryption what you are going to use, so level of security or the level of information hidden will be increases. So that is the job of your session, that is session layer. So after that, what we have as transportation layer. As I told you, the transportation layer, it is responsible for data transmission for the means it is a process to process delivery. So means what, even for each application we have a several number of processes to be implemented. So from which application or from which process the data has to be reached, so that will be done from the process to process delivery. So each process will be having some port numbers, so through the use of port numbers only they can communicate with the next process, or they can communicate with a higher layer. So through the use of these port numbers, the transport layer is responsible to transmit the data from process to process delivery. So if you need to remember that transportation layer is responsible for process to process delivery. And along with this transportation layer, it provides some additional features also. So what are the additional features it provides? It provides a flow control, and also it provides a congestion control mechanism in the network. So what do you mean by congestion control? I think yesterday class I have told you what you mean by congestion control. Can anybody tell me what you mean by congestion control? Anyone, if you remember? Can anybody tell me what you mean by congestion control?
Sir, it is done to avoid the telecommunication network, sir.
It is done to?
Avoid the telecommunication network.
What do you mean by avoiding the telecommunication network?
Sir, condition is nothing but a control mode which is used for monitoring a particular process or how much the total amount of data is entering the network so that it does not collide.
Okay, one example I will give you. Okay, Shreya. Now let us say we are having some activity, fun activity we are having. So let's say I am throwing a ball to you and you are catching the ball. So at first instant of time, what I will be doing is I will be throwing a ball, only one ball at a time for you. So what you can do? So since one ball it is can easily catchable, so what you do? You can catch the first ball. Okay, so the second time what I will do is instead of transmitting or instead of throwing only one ball, so what I will be doing is I will be throwing some two balls. So in this case, what you can, if your capacity means if you're trained to catch these two balls simultaneously, means then you can able to catch the two balls simultaneously with little bit difficulty. Now what happens is in the third time what I will do, okay, I understand that, okay, whatever I am throwing the two balls, she I can able to withstand that, and she is catching the ball. So what I will do is I will increase the data transmission rate, means I will increase the number of balls to you. So instead of two, for the third case what I will be doing is I will be transmitting three balls, or I will be throwing three balls. So what you can do is for the third case, with lot of difficulty you may catch these three balls, or you may lose some balls catching the balls. So in such a cases what happens is, yes.
Sir, what you meant to say is because if there is no condition, the router sometimes it becomes like really inaccessible and the other
Yes, yes,
packets drop. Like
yes,
network buffer or the buffer overflows sometimes
yes,
and the
yes,
data is
yes.
lost and it is unreliable connection.
Yes, yes, unreadable. That is what. So if the fourth case, what I will be doing is I will be throwing say seven balls simultaneously too. So is it possible for you to handle those seven balls simultaneously? No. So what you will do is you will simply leave all the balls. Why? Because since you cannot able to catch one ball particularly when seven balls are simultaneously appearing to you. So what you will be doing is it is not possible for me to handle this catching the ball. So I will leave it as it is. So means what, you will go in a condition or you will go in a scenario where you will not catch even a single ball. So that state we are going to call it as a network congestion. So the network congestion means what? It is a state or a ability of the device which cannot handle the traffic which is flowing across to it. So that state or that scenario we are going to call it as a network congestion. Yes, Shrey, anything to be told?
No, sir.
Okay. So that is all about your network congestion. So that network congestion, so what happens is, see, when I am transmitting the data, I should know what is the capacity with which the links are attached to data transmission. If whatever the data rates I am transmitting, if it is within the capacity of the data link between the transmitter and receiver, means then the data will be successfully transmitted from transmitter to receiver end. If the rate of arrival, if it is very large than the rate of departure from a particular link, means then some of the packets will be lost. If the rate of arrival is too large when you compare to the capacity of the transmission media, means so what happens is all the packets will be lost within the network. So what we should do is we should avoid this condition. Why? Because if the devices or if the node within the network, if they are not doing any activities, means then whatever the data you are going to transmit over the network, all the data will be lost within the network. If the state what you reach, we are going to call it as a congestion control. So therefore we should have some protocol in the transport layer in such a way that we should see or we should observe whether the network is going for congestion or not, whether the capacity with which the network has been built, if the rate of arrival of traffic it is very high when you compare to the capacity of the data what it can transmit over the network. If it is too large, means then you should instruct to the arrival rate of data rates such a way that so whatever the data you are transmitting within the network, it is very large, it is not possible for us to handle or it is not possible for us to flow within the capacity of our network. So what you should do is you should instruct the sender that you try to reduce your traffic rate so that I can transmit your data efficiently as possible. So this mechanism we are going to call it as a congestion avoidance mechanism. Okay, so we have some protocols. So we have protocol. Yes, Shreya.
Sir, condition control, does it have end-to-end encryptions?
So we are not talking about encryption. Encryption is the other part. Here what we are talking is whatever the data I am receiving, I should forward it properly without any loss of data. Encryption is about providing the security to your data. So what do you mean by security to your data? Some intruder or some third person don't want to access your data. So that is all about your encryption. But whereas here the congestion means it is whether I can able to transmit the data from my network or not. That is the case.
Okay.
Okay, so here we have some built-in protocols and we have some advanced protocols are there to detect the collision and to detect the congestion and to avoid those congestion. So we will be using we will be using those congestion protocols over the transport layer transport layer. So that permissibility will be given in the transport layer. Okay, so the next one we are going to call it as a network layer. So the network layer, what it does is it provides a data transfer from one host to host. So it is called as a device to device communication, or it is also called as a host to host communication. Okay, so the responsibility of the network layer is to forward the packet, or the responsibility of the network layer is to forward a packet from one device to another device only. Okay, but whereas the responsibility of the transport layer protocol is along with once you receive your data to your device, you should properly route that data to the corresponding application or the corresponding location where the data can be accessible or to whom the data is belongs. Okay, so that is what I gave you one example in the case. So yeah, of course the letter will be reached to your home only, but in that home to which person that letter is belongs, so that person only has to access that data. So that will be done by your transport layer protocol. Okay, so the network layer protocol, it is responsible for host to host communication, and this network layer protocol, it works based upon one important protocol that is called as a IP protocol, that is nothing but internet protocol. So through the use of this internet protocol, it will transmit the packet, or it will transmit the data from one device to another device. So in the universe, if you want to access the device, of if you want to know the device, means then it will be done only through the IP addressing. So means what, if I want to know what you mean by this device, means then I will be knowing only the IP address of that. So if I know the IP address of that, then I can easily communicate with that device. Okay, so therefore the network vendors, or whatever the devices which will be manufacturing for communication purpose, they all should obey this IP networking protocols only. Otherwise, you cannot have a communication through the use of other peripheral devices, so that the whole communication will be lost. Why? Because it is not only you are setting the communication only within some area or within some country. It is that the network you are building, so that the people around the world has to access your network. So what we are trying to say, that whatever the communication devices that has been implemented, or that has been manufacturing, all they should work with this unique IP addressing mechanism. That is, it should work on IP based mechanism. Okay, so this IP based mechanism, it is common to all the devices. So if you know the IP address, means then directly you can transmit the data to the receiver or the device. Okay, so that job will be done by the IP, that is network layer. The next one is data link layer. So the data link layer, we are going to call it as it is used for reliable communication between the links from one device to another device. Okay, so it is not that directly whatever you have a data from transmitter and directly you can reach to the receiver. It is not the case. Why? Because the users are geographically apart, far apart between them. So what we should do is, we should use some devices intermediate between them, so that even if it is not possible for me to transmit the data at a stretch to the destination, so what I will be doing is, I will be transmitting the data to the neighboring node, and this neighboring node will forward the packet to the next neighboring node, and the next neighboring node will forward the packet to the destination where it has been situated. So through the use of attaching the nodes and transmitting the packet from one node to another neighboring node, so we can forward this packet data. So how you forward this data? So when you're transmitting the data from one node to another node, so it has to be done in a systematic manner. So in order to done a systematic manner, we have created one layer called as a data link layer. So through the use of data link layer, the information which has been reached, that is a datagram, we are going to call it as. So the datagram, what it has been received from the network layer, it will take that datagram and it will convert that datagram into frames. Okay, so frame is nothing but a sequence of bits. So this data, this frame, it will be having a data, along with that it will be having a addresses. So these addresses, we are going to call it as a logical addresses. Through the use of these logical addresses, we can able to create a link from one node to another node, and we can successfully transmit the data from one device to another device. The next one, we are going to call it as a physical layer. Okay, so I have created a frame. So now these frames has to be converted into, yes Shreya.
Sir, the data link protocol layer which you were talking about now, in a program, it basically handles the moving of data into, like, is it a physical link layer? I mean, like, is it a physical link in a network? Like, from
No,
the
no,
data link, is it directly coming to physical link? Like, are we moving the data to physical link using a network?
no. Actually, see, all these layers are present in one node only. All these layers are present in a single node. So data link layer also present in the same link, same device, and physical layer is also present in the same device. So whatever the data you are going to receive from the network layer, that will go into data link layer, and that data will be transformed into frames. Okay, so whatever the data you are going to receive from the network layer, that data you are going to reframe. Okay, how? Through the by creating a frames. Okay, so for that frame, what you are going to do is, you are going to attach the link addresses. So link addresses means, so to which link the data has to go. Just that address you are going to attach. After that, what you do is physically you are going to transmit the data. So if you want to transmit the data physically, what you should do is either you should create a electrical signal or optical signal, or you should create a electromagnetic waves to transmit from one node to another node. If you are connecting physically from one device to another device means, then through the use of coaxial cable. So what you should do is you should have a electrical pulses or electrical signals you should generate, and these electrical signals will transmit from one device to another device, so that it will decode it and it will convert them into frames. So means whatever the frames you have created in the transmitter end, it has to be converted into electrical signals. So that job will be done by the physical layer. So this physical layer, data link layer, network layer, transport layer and application layer, all these layers are within a single node only. See, up to data link layer, it is only a logical connection. There is no physical connection is there. You will be getting physical connection only in the physical layer, and that to depend upon what type of link you are creating. If it is a wired LAN means, then you are going to connect from one line to another line. If it is a wireless LAN means, then you don't have a connection physically. Why? Because the data has to be freely can be moved in within the air. So in order to move your data freely within the air means, so what you are supposed to do is your data has to be converted into electromagnetic signal, that is EM wave, it has to be done. So who has to do? So your sender has to do it. So who has to do? The physical layer will do it. So whatever the data it has been created in the frame, so that frames will be converted into in the form of electrical signals. So this electrical signal, it may be electromagnetic wave, or it may be electrical signal itself, or it may be an optical cable. So if you have an optical connection from transmitter end to receiver end, so what you are supposed to do, your data has to be converted into optical signals only, light signals only. So for that you should have a converter. So that converter is nothing but your physical layer. So this physical layer, what it does, it converts your frames into either electrical signal, or it converts into light, or it converts into electromagnetic wave, and it will transmit to the next node. So how the nodes are connected? If they are connected physically means, then it will be done through electrical signal. Means the physical layer will convert your frames into electrical signals. If it is two optical cables means, then your physical layer will convert the frames into light wave. Corresponding light wave it will convert, and this light wave will propagate throughout the optical disc, and it will reach to the another node. So in the another node, what it does is it will convert, or it will transform your optical light into frames levels. So for that you need a physical layer. Okay, so this physical layer, what it does is it will convert the light signals into stream of bits or a frames, and these frames will be given to the MAC layer, and this MAC layer will do some other remaining task. Is that clear?
Sir, data link layer to physical layer is nothing but the vice versa thing going on, right, sir?
Yes,
Like
yes,
it's
yes.
transferring the data to the network link, and again, sorry, data from network layer to data link layer using the
Hmm.
frames. Again, data to physical layer. Again,
Hmm.
from data to physical layer to data link layer. Like vice versa, the process is going on using the frames.
Yes, 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 yes. See, up to data link layer, it is something like only we are doing with the bits wise.
Okay.
Means logical connection. In physical layer only, you are actually you are converting them into signals. Okay, so the data whatever you have, if you want to transmit means, it has to be done through electrical signals only. So that process will be done by the physical layer. Okay, so depending upon the link what we are establishing from one node to another node, so if the node is means, if you're using WiMAX or if you're using this WLAN means, then what we should do is we should use some modulation schemes for your electrical signals, because these signals cannot propagate for the longer distance. So what we should do is the physical layer should responsible for creation of modulation links, or the modulation scheme it is used, and through the use of modulation schemes, so we will generate a electromagnetic wave in such a way that they can propagate for the longer distance. So the node which is present at the far distance, it can receive that signal, and it will convert that signal into bit levels, and then from bit level to frame level, and then it will be go to the network layer. Is that clear? Okay, so we will go to the next one. Okay, and we studied about what are the deficiencies there in the OSI model. So what are the deficiencies? The first one is the cost of investment of this OSI model was very high, and the second one is there is no interoperability between the TCP/IP protocol with the OSI model. So we were facing some difficulty when we implement some protocols for the TCP/IP protocol. It was working very fine in the TCP/IP suite, but the same protocol if you use in a OSI model means it was not working properly according to the desired needs of the user. So therefore there is a interoperability conditions or a deficiency was there in a TCP/IP protocol with the OSI model. And one more disadvantage is that so whatever the functionalities which has been created in the OSI model, all the functionalities till now it has not been used fully. Okay, so some functionality we are not using, so there is a wastage of bandwidth or wastage of functionalities we are doing in the OSI model. And so for some layer there is no specific application or the functionality still it has not been defined whether this job will be done by which layer in the OSI model. So that is also one of the drawback of the OSI model. So these are the some of the drawbacks between or some of the differences between your TCP/IP protocol and a OSI model. So the you can see here so how the switch will operate, or if you connect any switch or if you connect any router, so how it will work or which are the layers are responsible when you're transmitting the data. So that is what we have studied in this example. Okay, so we will go to the next one is, so from now onwards what we will do is, so since in the subsequent manner chapters we are mainly focusing on a LAN technology. So how actually LAN technology will work, what is the difference between wired LAN technology and wireless LAN technology. So we will be studying in details about the LAN technology. So for that they are given you some preamble. So for you to have a preamble, for you to study this LAN technology, some prerequisites you required. So what are those some prerequisites? You should know the data link layer properly. So for that they are giving you a detailed analysis of the data link layer. So in this class we will start what exactly the data link layer and what are the differences are or what are the functionalities will be provided by the data link layer we will be seeing. Okay, so the data link layer, as I said you, it is responsible for generation of nodes, frames, and these frames will be transmitted from one node to another node within the network. Okay, and some of the services what this data link layer it is providing, you just I will have explained this already, so I will summarize over here. So the some of the functionalities of the data link layer is, the first and foremost is it provides a framing, means it will take the data from the network layer and it uses an encapsulation method so that the data frame or the datagram what we are going to receive from the network layer, it will be converted into frames. Okay, so that is nothing but bit by bit mechanism. The next one is addressing. So when you connect two devices, so the address of first device should be known to the address of the second devices, means the logical addresses you should be know before you connect two devices. So the logical addresses of the devices will be known through this data link layer. The next one is synchronization. So when you transmit any data, because if the transmission media if it is a wireless means, then should be a synchronization of data what you are transmitting from transmitter end to receiver end. So therefore the synchronization is necessary when you want to transmit the data through the use of this data link layer. So that will be done by the data link layer. The next one is error control and flow control. So when you transmit the data, you should make sure that the data should not be lost within the transmission media. So therefore you should use some technique in such a way that whether the error has been occurred for the received data or not. So for that we will be using some error control coding schemes. So that is nothing but error detection and error correction algorithm we will be implementing. So one of the important algorithm what we will be using in network model, we are going to call it as a CRC, that is a cyclic redundancy checks algorithm we will be using. So through the use of this cyclic redundancy check, we can able to identify whether the error is present in the given data or not. If it is error means, then we can able to rectify where exactly the error is there, so that we can successfully receive the data what has been transmitted from the transmitter end. And next one is multiple access. So with the use of this data link layer, we can have a multiple access capability within the transmission media. So what exactly that multiple access we will be seeing in the next subsequent chapters. Okay, so the next one is, there are two categories of links are there in a data link layer. So as I said you, it may be a point to point communication or it may be a broadcast communication. So in point to point communication, what happens is, so the devices are connected in a dedicated channel. In point to point communication, the devices are connected in a dedicated a single channel. Okay, so whatever the data it has to be transmitted, so the data will be transmitted in a dedicated channel only in a point to point. So means what? Single to single. So you have a transmitter, you have a receiver, the data will be transmitted through a coaxial cable which are connected between the two devices. So that is nothing but point to point link. There is one more link what we are going to call it as a, that is nothing but broadcast link. So the broadcast link, what you mean by single to many, that is we are going to call it as a that is we are going to call it as a broadcast link. So means what? We can pair different number or several number of devices within the given link. So that we are going to call it as a broadcast link. So why you need to study this broadcast link in this networking concept is why? Because so since we are moving from wired LAN to wireless LAN, so therefore it is necessary for us to know, so what are the devices we are currently transmitting the data within the channel. So in order to know what are the devices the currently the data are transmitting by the nodes, so for that we will be using this broadcast channel. Or if you want to synchronize within the network means, then we will be using some broadcast messages. So means what? One node will wants to have some information from all the rest of the nodes. So in that cases, it will be transmitting the broadcast signal. So broadcast signal means one node will be transmitting to several devices. So we can have a several devices connection for the single transmission media. So that is nothing but your broadcast link. Okay, so the next one is, so when we talk about the means what? So when we talk about the analysis part, or when we talk about what exactly the data link layer, so we are going to practically we are going to divide this data link layer into two sub layer. One we are going to call it as a data control, that is a data link control layer, and one more is called as a medium access control. We are going to divide, means this layer will be divided into two sub layers. One we are going to call it as a data link control, or it is also called as a logical link control layer, we are going to call it as. The one more layer we are going to call it as a media access control layer. So that is nothing but MAC layer. So if you had, so if you know what you mean by MAC, what you mean by MAC address, I think so you will be already knowing it. So all those details we will be learning in this medium access control mechanism. So this logical link layer, it is responsible to have a interface your data link layer with the network layer. Logical link layer, it is responsible to provide an interface from the data link layer to the network layer. So it will do some functionalities which are related to point communication, and also which is related to broadcast communication. So all those functionalities we can incorporate in a data link control sub layer. Whereas in the case of medium access control layer, only the broadcast issues, so whatever the broadcast issues, so we will see what are the issues are there in broadcast. So means when we talk about a wireless LAN technology, so there we can able to see what you mean by broadcast issues. So these broadcast issues will be taken care by the medium access control sub layers. So in wireless LAN technology, what happens is, so when before I transmitting the data, I should access the channel. So if the channel is free means, then I should transmit the data. If simultaneously two transmitters accessing this channel means, then there will be a lossage of data will takes place within the network. So that lossage of data we are going to call it as a error, or that is why you're going to call it as a data lost. So we don't want to have a data loss within the network. So therefore, in order to avoid the data loss, we are going to access the channel before we transmit the data. So that mechanism we are going to call it as a channel access mechanism, that will be done by your MAC layer. Okay, so these are the two links you can see here. In the case of broadcast link, both the mechanism will be working. So that is nothing but data link layer and also the MAC layer will be working. Whereas in the case of point to point link, since there is a point to point link is there, there is no any necessity to have a congestion in the data, because from one transmitter one receiver is there, so the data will be transmitted successfully without the accessing mechanism. So therefore the data link layer sublayer is responsible to provide the point to point communication. Okay, so that is all about your data link control sublayer. Okay, so now what happens is, so along with this IP address we should have one more address, that is nothing but a MAC address, we are going to call it as. So this MAC address, it is nothing but a logical address. So through the use of this logical address we can able to establish a link from transmitter end to receiver end. So how you establish that link, so that is all about your creation and generation of this MAC addresses within the network. Okay, so when you want to transmit any node, any data from one device to another device, even though if you do not know the IP address, it is necessary for us to you to know the MAC addresses. So because through the use of MAC addresses only we can able to transmit the data, we can able to transmit the data from one node to another node successfully, and we can able to forward the packet from one device to another device successfully. And and when you connect to any network, so by default you will be having a IP address, but you will be not having a that is a MAC addresses. So how to do that? To get a MAC addresses means, then you will be broadcasting your IP address to the corresponding router. So through the corresponding router you can able to get what is your IP MAC address. So through the use of MAC address we can able to establish the link from one device to another device, so that we can transmit the data. So therefore what it does is, so when you want to access the network you should have a MAC address. So this MAC address, it is having two types of address within it. So one is called as a link address and one more is called as a physical address. So combination of this link address and physical address we are going to call it as a logical address. Okay, so you can see here, when I want to transmit the data from Alice to Bob, so how the establishment of data will takes place, you can see it over in the diagram. So you can see here, Alice, it is a device, so which is having a you see the N is nothing but a IP address and L is nothing but a link layer address. So you can see the datagram. So N1, N2 data. So this we are going to call it as a datagram. So this is the data we are received from the network layer to the MAC layer. So what this MAC layer will does, so you can see here, it will does the link address of the source L1 it is appending, and the link address of the destination to which this device is connected. So this device is connected to the router through link L2. So therefore it is mentioning the link address, that is L2. So therefore the data will reaches from the first device, that is a transmitter Alice 2, it will reaches to the device router 1. Now this router 1, what it does is, where exactly this receiver is there, it will check in the routing table. So based upon the routing table information, it will check through which link I should transmit the data. Okay, so based upon the routing table what it is having, it will check through which link I should transmit the data, so that it will reach the destination as early as possible, or with the minimum number of hop it will transmit to the receiver end. Okay, so that will be, it will check. So the link is from L4 to L5.